Hello friends, welcome to another video in digital signal processing. In today's video we'll talk about Mpeg, which is a very popular standard for video encoding. Mpeg has video extension with MP4 and audio extension with MP3. There are various standards for Mpeg 1, 2, 4, 7, 21, out of which Mpeg 4 is very famous. It has lossy video compression and it has very high compression ratios of 15:1 or 20:1, but considering these high loss ratios, the quality is still maintained at a very decent level, so it is optimized as compared to the losses it produces. Now Mpeg is similar to JPEG. The same compression technique is applied to individual images of Mpeg, because a video is made up of various images in sequence, so whatever compression is applied to those individual images are applied to all the images in the sequence for Mpeg. So if you know JPEG well enough, understanding Mpeg would not be a problem. Now let's talk about Mpeg compression flow chart, or the block diagram. The block diagram of Mpeg consists of 4 blocks. The first block is data preparation, which is similar to JPEG, and the second block is data processing, third block is quantization, and fourth block is encoding. In data processing we do motion prediction, and then we do discrete cosine transform. Then we have quantization, and encoding is done through entropy encoding. Motion prediction is a very important part in Mpeg because we do not need to compress all the images again and again, because there is a lot of similarity between the consequent images. Now depending upon the standard used, data is prepared, but in case of Mpeg, the subsample chrominance signals is in the ratio of 4:1:1. Now what does that mean? That means that this is the ratio for luminance, which is known as the brightness, and this is known as chrominance, the kind of bluishness that we have and the redness that we have in the picture. Now depending upon NTSC and PAL, the subsample space of brightness is 352 by 240 pixels, and then it is divided into again 4 parts of 176 into 120 small blocks of CB and CR. So these CB and CRs are behind the luminance block, but they are 4 in numbers. For each chrominance block you'll have 4 CB and 4 CR blocks, and similarly by the way, you should have this value is wrong, because you should have double the value of this, so this should be something of 250 something, double of this. So the macro blocks, there are 16:16 samples for luminance and 8:8 samples for chrominance. Now when we talk about data processing, we apply the motion prediction at macro block level. As you see, if we divide this block into 16:16 samples, we'll have number of macro blocks, and the data processing is applied to macro block level, and we apply predictive encoding, and motion prediction is used to predict the macro block next frame. So if the prediction is based on previous frame, it is known as forward prediction. If the prediction is based on future frame, it is known as backward prediction, and if it is dependent upon both previous and future frames, then it is known as bidirectional prediction. Then depending upon what kind of prediction is applied, we have frames of Mpeg, we have I frames, P frames, and B frames. iframes are independently encoded. There is no temporal predictions on iframes. I stands for independent, so we need to, it is a must to apply encoding to these frames. And P frames are forward prediction frames, and they are based on previous I or P frames. Then we have P frames, which are known as bidirectionally predicted frames based on previous and following I and P frames. And the concept of GOP, which is group of pictures, we have set of frames between two iframes. So we could have two iframes. Now these are independently encoded, and between them we could have B's and P's. So this will be known as one group of picture because two eyes are there at both the ends. And then the need arises for the buffer, and DCT in Mpeg is applied on 8x8 macro blocks, and we convert a 2D image into 1D series using encoding, and we could use zigzag scanning or vertical scanning, and we could use run length coding in 1D series. Now, depending upon the values in an 8x8 block, we decide whether it's a DC signal or an AC signal, which is a misnomer, by the way. DC corresponds to smaller values or values closer to 0, the normalized values, and AC values corresponds to very high value. For example, if you look at this is a DC pixelated image because all the values are normalized to 0. So with respect to 0, all the other pixels are expressed, and we can use zigzag encoding like this, which is a very famous encoding technique. Something like this, to convert a 2D image into a 1D image. So we'll have 100, 0, 0, -1, 0, 1, and so on and so forth. And what are the advantages of Mpeg? We could use different compression levels. We have a wider variety of browser support, and it is compatible with media software. It is better than AVI. And that's about it that I needed to discuss about Mpeg. I hope you liked the video. Give it a thumbs up if you liked it. I'll see you around.